Hello everyone and welcome to the Buidl radio podcast where we talk all things blockchain and all things technical. Today with you our host, myself, Polina Ladina, and Andrei Sobol from ZCash. And our dear guest today is Gregory from ChainSafe. So welcome, Greg. Can you please tell us what are you competent about and what topics should we totally ask you about today?
Hey, thanks for having me. I'm pretty much good across the stack. You know, at ChainSafe, we do a lot of protocol implementations. I started out kind of working on Lodestar E2 implementation a couple of years ago. So I can kind of talk really low level down there, or also kind of where my passion sits a lot of time is at, the wallet layer, and kind of like the interactions and interfaces between DApps wallets, nodes. So kind of happy to pretty much cover the full spectrum except for smart contract development. I don't think that's where you'll get the best content.
You actually kind of guessed the next question is the question is what are the things that you're not competent about and what we shouldn't touch during this podcast?
Probably let's veer away from like the DApp development side of things. From the perspective of like smart contracts, because I don't spend as much time there. I can read them and stuff, but I don't know what's new and hot.
So we won't talk about smart contracts. That's good. Okay, so once preparing to this podcast, you referred us to a thread about privacy, and it kind of mentioned dApps and wallets and how they interact in between each other. So let's start with dApps here. Like, why does a dApp called a dApp? And even though they call dApps because they're decentralized, right? But if it's still there, most of them are centralized in regards that a lot of data is stored on server, so you can have all the cache and you can load it fast. But why do we still call them dApps?
That's a good question. I think generically speaking, if it interacts with a smart contract, or into that regard, where they're like a wallet signing something and then it goes to a smart contract, I think the idea is that that's generically a DApp. I think there's a huge pitfall that sits there, which is in terms of hosting. Where is that information coming from? How is the data getting served to the DApp? How is the DApp serving data to the user? Those kind of main points really are where the breakage hits, and where the term decentralized application is a little bit misleading. And I think it's really just an application that interfaces with the blockchain. There's very few applications that are truly raw decentralized. Those are ones that pretty much, if you can access it through something like IPFS, you're pretty much on the right track. I'd say for the most part. And so, because typically there's no backend proxy server people are running, and stuff like that.
Okay. So the DApp technically is meant to be stateless, but it appears to be that it's kind of stateful. Well, an exception probably is hosted on IPFS. So how do you think why they don't want to run centralized app, but including the RPC within the application?
Yeah, so the RPC layer is a little bit tricky. And I tried to explain this at ECC once, this past year. Basically, I think there's just a lot of misunderstanding in the education and how people can get access to the data. So for those that don't know, the fundamental part, the RPC is how you're going to get access to read and writes to the chain. It's connecting to a node. And so when you're building a app that doesn't have a backend server to effectively proxy you to an RPC node. So, user connects and you're getting the data fed through some backend server, because you obviously don't want to give public access to a node. Otherwise you'll just get that address will get bombarded if it was an Infura key or something like that, or just your own private node. Typically what people do is what wallets do is wallet providers. So metamask or Frame, Xerion, whatever, when you connect, they'll bridge a RPC provider to you. That's because, your phone app, your extension might will most likely have access to an RPC, so that it can show you data about your wallet balance and tokens and whatnot. And typically then what these wallet providers do is they tell the front ends and applications you're using that, hey, here's an API that you can access that gives you full read access to the RPC node. The problem is a lot of front-end developers don't actually know that this is a thing. The common convention you see is if you go to a website, like a DApp, it'll all say like, hey, connect to your wallet, and you have to like forfeit an address. So you're basically forfeiting an address to this DApp, and then it starts doing read. It starts like pulling information to like load the website. That's not necessarily needed, right? Because if you like, for instance, if you go in MetaMask and you go right now to window.ethereum, you'll see that you have like full access to the read-only side of it. So you can get blocks, transactions, all that stuff, just like nothing specific to a specific address, and you can't write anything. Yeah, I think that's kind of where like our problem sits in terms of accessing the RPC. I think because dApps try to be decentralized and they don't want to host their own key RPC provider for the user, they start basically abusing access to the RPC that's available to them.
Related to RPC, you really promote to have your own node, but like it's really expensive. By the way, how many money you will spend if you will use your own RPC nodes?
It's not actually that expensive because conventionally running your own node is typically nowadays is like, hey, you need staking or you need like a lot of historical data and stuff like that. Most of the time, you don't actually need a lot of historical data. Most apps only like pull latest block. In some cases, you might need historical blocks up to like maybe 1,000. And so because of that, you actually don't need a lot of data, and you can be like on the heavy pruning side, which means you can actually run this whole setup on ARM. Ethereum on ARM, I don't have it handy on me, but like their Twitter page has a link to like things you can buy, basically like a shopping cart to like build a node. And I think you can get away with something that will last the next like 2 years worth of state size, for like just around $100, $150. And this can be totally built on a Raspberry. When I say ARM, I mean like built on a Raspberry Pi. This runs the beacon node. This runs the Ethereum client, and you're basically just running like a super, super light version. And that's all you need, because you got to remember, you're not handling requests for like the whole world. The idea is you're handling requests for just yourself. And that means this is like low bandwidth. It shouldn't be like doing a whole lot of reads and writes to the chain. And even if it's a little bit slower, like you're doing the right thing on how to use it, on how to use like a blockchain.
Yeah, but if you don't want to spend this $100, you can use the Lite client, right? I understand the security assumptions of the Lite client in Bitcoin. You have this Bloom filter, you have this Merkle tree of transaction, and you 100% sure, no matter what your server will show to you, no matter what it will show to you, you know that if you know all headers on Bloom filters for a particular address, you know that there is no like missed transaction that it's related to your address. But how it can work in Ethereum, how you can prove that some transaction is really included in some batch of data that full node will provide to your Lite client. What's the security assumptions here?
Yeah, so this is a really funny problem. In the pre-merge era of Ethereum, Lite clients worked. The problem was people didn't run a Lite client. You had to explicitly run a Lite client server, and there was no incentivization for a full node to run it. So like in Geth, for instance, it was by default off. But the proving mechanisms were there and they worked. It works very similar, using the Merkle tree, kind of like traversing it and giving you like some proof results back from it. And then you could basically take the results of the Lite client and ask, there's a method called getProof, an RPC method on the nodes, and you could use getProof to basically go against any other full node and prove that, the data you saw is correct. That worked in the pre-merge era. In the post-merge era, the beacon chain has Lite clients set as a first-class citizen. So this means that no matter what, you have to be able to serve data for a Lite client in order for them to like operate on the network, which means that, we have that ability right away. But there's a big gotcha right now. And the gotcha is that we can prove consensus data, which is like on the beacon chain. We can't yet prove execution data as a part of like the first class citizen like client approach. This is due to a few technical limitations that will come from a few. I think the next hard fork's including it. I can't remember the EIP number off the top of my head, but basically it'll allow us to get like the block header data and be able to prove it, that we can say like, hey, this actually happened. Right now, there's been a few implementations of light clients that have been built, one by a VC group, one by an individual. Both actually don't fully work because they still technically need an ETH1 RPC provider, which just kind of defeats the purpose. But the general gist of the idea is like, the one is using Lodestar, Kevlar, which is awesome. And it's using Lodestar's light client to like basically like the light client we built to like prove that all the like data submission is correct, proving that stuff has been finalized and all that, and seeing the attestations kind of work through that way. But again, it still needs that ETH1 provider to like really get the execution data, which is where smart contracts are. The other implementation is kind of misleading. It doesn't totally, it's not really a light client, but rather it's kind of doing the same approach of just pulling data and just saying like, oh, this data has been finalized because this execution block X has been included in, consensus block Y. And so now you can trust the data from that RPC provider. So it's more of like hey, you can trust this data versus like a true light client, right? Which would say that you don't technically need that access to a node. And you can just talk to a smaller subset of peers. And so that's kind of like the landscape of light clients right now. When dank sharding, proto-dank sharding comes in, we'll be able to actually do a really fun proof. And this is sorry to answer your question now. We'll be able to do a really cool proof, which is like currently in a Merkle tree, you have to prove every leaf, alternating leaf, going down to like the very bottom. Or not leaf, but every node in between. You have to get to a bottom leaf. You have to prove every node in between. With proto-dank sharding, you'll basically be able to like cut that like completely in half, and you can do like a linear path down, not a full linear path down, but effectively like a linear path down, which means you like completely save on costs in terms of what you need to query to like rebuild that state, which will make light clients really, really light, like super light. But that's a little ways away, I think.
It's interesting thing. I didn't think about a KZG commitment like things which can simplify light clients, but for now I understand that it's possible. But before we get this like roll-up centric roadmap, we have the idea that we will have like some execution shards, different execution shards, and we will have the beacon chain where we have like light client as first citizen things. In the execution shard, we also will have this first citizenship related to the light clients, and we will somehow in the future deprecate current execution layer. But for now, when we do the things related to the dunk shards, proto-dunk shards, etc., for now we understand that we will keep our current execution layer and how it will work in this case. So that means that like Ethereum will never have the good light client approach, or how it will work.
This may be like more opinion based, but like I don't think the current L1, the execution layer we see, will ever disappear. I think that we'll get to a point where the incentives are just so much greater that people will probably build outside of it, and that current execution layer just becomes kind of like that roll-up state where people kind of roll up to. That might be just a personal opinion. The idea of like sharding too, I mean, I think it's still up in the air of like how that will be implemented and will it be implemented, but like we can get into that at a different time. The way that light clients will work and continue to work there, I mean, like, so we kind of like need a two-way communication between the execution layer and the consensus layer, to like have like the full spectrum of light client stuff. And so one of those things, there's like a few things that are kind of related to light clients. They're also kind of not related to light clients. But like so basically we need, to be able to prove like the full block header of the execution client in the consensus layer for us to like have that. And then we also want to be able to prove so that like a light client can just like get and prove data, from the execution layer. So that's kind of like the missing piece. There's some cool things that we can do also down the road that aren't totally related to light clients, but like have used similar concepts, which is like effectively getting the consensus layer headers included into the execution layer. That'll allow DApps to like understand finalization. So like a smart contract can like know and understand finalization, which could also be seen as like another way to like leverage like clients in the future. Yeah, sorry, I kind of lost track of what you were asking me
there. Okay, let's come back to the KZG commitment and light client things. The last questions that I will ask you, so like for KZG commitment, we need trusted setup, right? So for in this case, for a light client, we also will need trusted setup.
The light clients don't need a trusted setup because it's like it's part of the protocol of like how the proof structures work and how like getting the proofs work, right? Now doing the KZG commitment, like doing that restructuring, that obviously has a trusted setup, which I think starting in January, if I'm not mistaken. I think Trent put a tweet out the other day. But yeah, light clients won't need that. Simply because they're just like another node accessing data on chain, but they're just doing it in a different way, right? Because they're looking for like subsets of data and the proof on how you got that subset of data. Just for like clarity, a light client's like goal is to just like query a small subset of a large data set, and then it to also have a proof of like to like say like this data integrity is strong, and then I should be able to take that proof and that data and send it to any other node, and they should be able to return like a boolean if like it's accurate or not. That's the objective of the light client, right? In a really LS5 way. So there's no commitment ceremony. There's no like trusted setup there, because you're effectively already trusting that you're getting the correct information from the nodes.
As we talked about light clients and a little bit about the wallets now, do you think it's possible in future for the wallets to actually include light clients inside like extensions, for example? Could light nodes in browser actually work?
Yeah, absolutely. This is like fundamentally why we started Lodestar. So like for those that don't know, Lodestar is a JavaScript, I guess it's TypeScript, but it's a JavaScript TypeScript implementation of the beacon chain, and subsequent like tooling libraries and stuff like that. And one of the main purposes was basically to have like that fundamental building block for DApp developers to use to get to like a fully decentralized system. You know, our main focus is light clients. We've got everything else running, but like the idea is like you should just be able to import this library, plug it in as like into like Ether's Web3.js, the same way you'd kind of do that for like an RPC provider. Instead, you'd plug in like Lodestar as an RPC provider, and that's it. Honestly, I think we'll start seeing DApps doing this migration within the next year, as long as like the EIPs land that should. That is like really the future, like next step to having like fully decentralized applications, because you'll no longer need to rely on like a third party RPC like Infura or Alchemy.
Related to light client, maybe a little bit overthinking about it. But is it possible that the technology like Coda/Mina, like ZKVM, which we can put into recursive snark, solve this problem in the way that you don't need to prove anything more than you prove for like layer 1? When you use layer 2, you just use this like zero knowledge proof for showing that your transaction is correct, this state transaction is correct, or it's not possible in the way that the time for proof generation, it will be very, very slow.
Maybe I'll use bridges as an example of like where it has its like pros and cons. So if we look at like a ZKVM bridge, which I think there's like a few of them kind of like out there, like there's some effectively like a lot of the ZKVMs like doing like the recursive like layer 3 to like 2 to 10, for instance. They're technically using like a bridge, like a ZKVM bridge to move stuff. That works really well, right? And that kind of solves the problem because you can see the commitments on chain, they're there and whatnot. Where the pitfall lands, though, is again back to like the L1, because the L1 is not a ZKVM bridge, and it's right now it's a Merkle Patricia tree. I mean, eventually it'll be proto dank sharding tree. I don't know. You still have that like fundamental problem where like you can't prove it because when you want to prove like through a bridge right now, we need a light client to exist. Otherwise, you need to like have store the full DAG on chain for you to like do the proof properly. This is why there are no trustless, there's like very few trustless bridges that exist between, actually there's zero trustless bridges, I think, that exist between two EVM chains. And this is because like you can't, well, you can have it one way, you can't have it both ways. For instance, let's use the Near bridge. Near is like one of the only ones that I know that exists. So they've got this thing called the Rainbow Bridge. It's trustless, like technically one way. Well, actually, okay. So Near chose an algorithm. I think they chose SHA-3 as their hashing algorithm, or they chose the exact one that like is implemented as a opcode within Ethereum. And so because of that, they can prove their state transition on Ethereum. So then we have that trustless side done. And they designed their chain specifically to be able to prove the Ethash like DAG on their chain so that they can make this like trustless interaction occur. And that's like the only way you can do it. So understanding that, we still need light clients, because if we had a light client, we could do that whole thing without having to prove the entire DAG to like make that bridge work. Which is why like I think ZK EVMs and whatnot kind of solve the like one story, right? And like how you can access data really cheaply, but they don't really solve like the full story. So that's why you still will always need it. Also, I don't think technically like you still, because the idea of like using a light client as a DApp in a DApp is to remove the need for access to a full node, and because like full nodes require you to like fully sync up the chain and whatnot, light clients just would peer to the protocol directly. They use a rendezvous server, so there's a little bit of a centralization there, but like it's the same thing as like using boot nodes, and you just spin up a node. So it's kind of like boot nodes that kind of rendezvous you, and so like that's why you always still need it, is because like you still want to get access to data. Whereas like the ZKVM stuff, like to get those commitments, you still need a node, right? Because you need somewhere to like pull it. So I think it's like solving two different problems in a really long roundabout way.
I can confirm that the Patricia Merkle tree that you mentioned, it's really a key problem in this case, because as I know, there is a scroll version of the KVM which developed by Scroll, and there is a fork of the Scroll which like exists in something like privacy. I don't remember exactly the name of this repository, something like privacy coin something or whatever, I think, which are maintained by Barry Whitehead. And one of these repositories, they use a Patricia Merkle tree, and they try to prove the Patricia Merkle tree inside zero knowledge. But Scroll, the original Scroll, they give up and they change it to some different way of commitment of committing data, because they say that it's too expensive. We cannot prove it so cheap as we expect in the way we will use Patricia Merkle tree.
So in the presentation that you mentioned at the CC, you also mentioned that usually when people create mnemonics, there is +1 word that goes at the end, which is also usually set to the empty string. So, and then technically, you can have like this honeypot of money saved using the password as the +1 word, and then you can have like a sneak, like a 5% deposit kind of on your main address where you just use the empty string instead of last word. So technically, if attacker actually knows that this password capability exists, would it be easier for him to like get the funds? Does it actually work?
Yeah, good question. We call this, like, I think Richard Moore dubbed this squirreling, like SQRL, because it's like squirrels bury their nuts, for winter. So it's like you're kind of hiding.
Forget about that.
Yeah, it's kind of like, set it, forget it. No, so like the idea is it's adding just like extra entropy. So as long as you use something, it's kind of like one of those things that if somebody found your mnemonic and then they found like 5 ETH on it, the chances of them to go and, start running through random extra pieces of entropy after that to like see if you have more it's possible. It's maybe a little low. The idea also is like you don't make it password 123, or like I wouldn't make it Gregory, something like dead obvious. And maybe you make it a little bit challenging. So the answer is like yes and no. If it's one of those situations where, oh my goodness, someone had a collision and like with your mnemonic and found it, at least like they'd find just that, and they probably wouldn't go to the other one. Highly advised if you want the full version. My ETH Denver talk really talks about squirreling. If this is confusing you, but yeah, like the safety guarantees, it's like one extra little bit of safety guarantee with the drawback that now you have an extra word you have to remember, figure out how to write down, figure out how to store it properly. Because obviously, like storing it with the main mnemonic set defeats the purpose. Because the whole purpose is like, oh, I lost my mnemonic, those 24 words, but I know this, like, you know, but like because there's a 25th one, that one extra one that's like that entropy, you should be able to, you know, let's say someone starts draining your funds, realistically you have email alerts set up, maybe with like Etherscan, because you should never touch that account. Oh, you see that happening? You shouldn't start sweating. Maybe you should be a little concerned that you know you have time to like go to your wallet and, you know, go to the version with the entropy added because it gives you new addresses, start rotating your funds out. That's kind of the gist. So like it depends on like how you want to set up your security practices around that and stuff. But I think it's quite safe. As long as you pick a good password.
Yeah. Well, very true, very true. But now you also have one more thing that you should not forget and store separately and securely as well, along to the mnemonic phrase. Okay, so talking about mnemonics, do you think like MetaMask can potentially be a spyware, considering they're using like additional RPCs and you can technically put your mnemonic in? Is there any way to actually steal it there?
Let me preface this with the MetaMask team are arguably some of the brightest people in the JavaScript security space that exist, especially browser security space. And I have like a lot of faith for like Dan, Taylor, Eric, and Kumavis. Like those are like kind of like the OGs from the team who kind of started. Like I have a lot of faith that like they probably wouldn't stick around to work on the project if it was going in a negative direction that would be like harming users. So I'll start with that. Also, like Kumavis has created something called LavaMoat, which is like this. You should look into it. You know, feel free, definitely look into it. It's called LavaMoat. It's for JavaScript. It's probably one of the coolest pieces of tools. It basically is like a sandboxing environment for JavaScript that isolates packages you install based on a permission system. So the idea would be, let's use what's a common package here? Those that were back in the day, like the underscore package, the infamous underscore package. Basically, you could say like underscore is not allowed to access my file system. It's not allowed to like connect to be browser compatible. It's not allowed to make HTTP calls. And so this is developed in-house by one of the people at MetaMask, and MetaMask is fully wrapped in that. So you can actually see what scoping permissions MetaMask has. And if you look at where like the mnemonic is stored and whatnot, it's very, very well scoped. So you like, no, I don't think you'd be able to access it. I think it's locked down really, really well. And I answered that in a very long-winded way just because I want people to really hear like the security side first versus an opinion piece. Because like, yeah, I have an utmost amount of faith for that team. And especially since the My Crypto team joined, I mean, there's a lot of great people there. But like between Harry and Taylor alone, like Harry is kind of like he's like the unsung hero of our space, you know, when it comes to phishing scams and stuff like that. I don't think there's anybody that's taken down more bots than he has. So you know, that team's like a powerhouse at MetaMask, and yeah, I don't think we're going to be seeing like compromised accounts from there. Definitely not.
I have very, very straightforward question.
Okay.
Is MetaMask spyware?
No.
Why?
Why would it be?
Because they have like I don't see a reason why I will not like collect data about millions and millions of crypto users. Why not?
But I mean, you can like compare the binaries that are like released and like downloadable, and like there is no spyware in there. Like there's nothing that's like spying on you as a user.
But what about default RPCs clients? Can we say that Alchemy or Infura is a spyware?
I can tell you that I think spyware is a loaded question. I'm not trying to defend either of these two, by the way. Like, I'm very pro run your own node. But that being said, I don't know if people intentionally are trying to spy here or do anything like malicious with the data. Do I think there's a huge security hole? Yeah, absolutely. You know, collecting that much user data about people is like dangerous. We have to also look at how to run big systems that take billions of requests per day, I would say, arguably. I don't actually know, probably per day. I remember back in the heyday, Infura did a talk saying like they did 1 billion requests a day or something. So I would assume they're all kind of serving some astronomically large, you know, to run the load balancers and the Redis servers and God knows what other custom software they're running to like handle that load. Like, you are going to need to start to correlate stuff together. And like, that's because, you know, you're going to want to start caching things. You're going to want to know who's making these requests so you can send them to the right caches. I feel there's a lot of people in our space that haven't like been and interacted with really large systems. I personally haven't, but I've taken time to like chat with people that have, to like understand this stuff. And I've known people that have worked at like large corps. Some of these services, like RPC node providers, unfortunately, like have to keep track of some of this stuff if they want to be super, super efficient. You know, are they trying to intentionally be spyware? No, absolutely not. Should they delete the data after a certain amount of time? Absolutely. Defaulting your RPC provider, I'm sorry, but like every wallet is at fault here. I would love to know how many wallets are using like Infura as a backend or Alchemy as a backend and like pretending like they're not. They're all probably guilty of it. This is where I kind of go on my little rant, and I'm going to stop now, but like, we're all guilty. DApps are guilty. You know, like there's probably like some freaking, like, okay, if you use Render or one of those like services to like load your DApps for people like really easily, like I can almost guarantee you they have some sort of caching analytics shit going on in the background that's like has an IP and an address log. And like if that service goes down and gets like exploited, then like it's like, you know, it's like, it's over. Like, so I don't know. I could go on this for a while. A lot of people like don't understand how browsers work either. The basic HTTP call has headers. There's so much data that just like is gone the minute you like interact with stuff. That's why we should have Mist. Mist was great. Mist, we should bring back Mist.
How do you think, like, there is on Amazon you can actually run a full nodes. Do you think it will resolve the issue, or will it complicate the issue with someone hosting your nodes, like Amazon?
Someone's hosting your node. Like, this is what I'm saying. For like $100, you can like get it set up locally. You want to know the best case, like protect your privacy the most. I mean, you can still do a lot of fingerprinting with like, based on like how transactions are being sent through the mempool. Different topic. I'm pretty sure Block Native can totally, but wait, who is Block Native the one that has the mempool explorer? Yeah. I think like they could probably fingerprint the entire mempool to the point where they could probably figure out like if you're running your own node, what transaction it's coming from. Like they could probably figure out like which signed transactions are originating from your node. I wouldn't doubt it. But like best case scenario, you pull down your stuff from IPFS locally and you're running like the app locally. You connect it to your own node that's running locally at home. And you're feeding transactions to it that way. You connect via like a proxy server to your home network or whatever, and you're sending transactions and receiving the data that way. You're like, that's probably like the best case scenario, as secure as you could ever get. I just don't think we're probably like another year away from like that even being a reality for the most part. I think the UX is really bad.
Well, that's kind of a lot of privacy in this regards, and also a lot of efforts to do that. So why do people actually need privacy? Is there such a thing as too much privacy in this regards? Because, yeah, so much effort, and what are the potential consequences of the lack of privacy here? If someone gets your address or if someone knows where you are technically, what are the potential stress out there?
I don't think it's from a threat perspective. I think it's from listen, there's some people that definitely could be at risk. Those are people that try to be anonymous and stuff like that. You know, I don't see that as mine. I see privacy as like a fundamental requirement for like us as, you know, civilization to operate. We need some level of discretion, right? Currently, none of you have access to know, you know, details about my banking. I don't have yours, you don't have mine. It's pretty standard. This is like pretty basic privacy. Like, I don't necessarily want you to see everything, and you don't necessarily want me to see everything. This is why, like, it's amazing we have multiple accounts, right? You know, I'll be super honest. You look at gregthegreek.eth and you see Tornado Cash entries. And, like, that's how I fund it. I fund, like, 1 ETH at a time just to pay for, like, DAO interactions, right? And that's just simply because it's not like it's not like people are trying to, like, evade taxes or anything. It's like both accounts are, like, taxed. I just don't want you to see both. You know what I'm saying? And I think it's, like, that level of, like, discretion that is, like, required. You know, I think Vitalik made a really good post about this one day with Tornado Cash, which is like, listen, you know, I might not want people knowing, like, what I'm voting on in, I don't know, Compound, let's say. Imagine I, like, participate in Compound. And I don't want sorry, that wasn't it. It's like charities, right? You might not want people to know what charities he's donating to, because that might, like, not be good from a public perspective, but it's, like, you know, morally the right thing to do. I don't know. There's a lot of reasons for it. Yeah, I could go. Yeah. I think, like, the general gist is, like, it's like a basic requirement. I think is that, like, we as individuals, like, you know, always have. We don't want to disclose everything, and it's not out of, like, malicious intent. It's purely out of, like, you know, personal privacy. I don't know. I think it's just like everybody needs it. And if you don't have it, I think we're, like, probably in a bad place.
Yeah, but then again, a lot of people are just continuing to give away a lot of private information to, like, Facebook or Google. Actually knows so many things about people, locations, restaurants, where did you Google on Google Maps and things like that. Like, very surveillance. And again, if you want to actually access bank services, you will need to reveal all your private information to the banks. So coming from Web 2, it's kind of embedded into, if you want to use service, you have to give the private information. How would you think in general blockchain will influence this trend, and what it gonna look like in future?
There's two kinds of privacy we're talking about here, right? Which is, like, one entity keeping that, knowing about some private information and not disclosing it publicly, versus things that are public record and can be looked up at any point, right? And I think those are two kind of different forms of privacy. So it's a good point you bring it up. I have high hopes that zero knowledge tech becomes a lot more adopted outside of, like, the blockchain space. You know, I don't necessarily care to see. One of the biggest things that I'm happy to see about what we're doing today is not that, like, hey, we're bringing blockchain to the masses, but, like, a lot of the tech and, like, invested money, grants, VCs, whatever, is being, like, built to support, like, the software community at large. And I think that zero knowledge tech is probably going to be one of the few things that really breaks free and kind of becomes its, like, own living, you know, spectrum. Like, in the future, I definitely kind of see how we have, like, AI, ML, we've got, like, blockchain tech, we've got, like, all, like, the major categories. I completely see in the next, like, 5 years ZK being, like, its own category within, like, the tech world. You know, you'll see, like, what's new in ZK on, like, tech blogs and stuff in the future. I think that's because it just opens up so many, like, realms of possibilities where eventually it'll kind of make sense. And there's a lot of countries and a lot of places that are, like, pretty progressive about this stuff. Honestly, one of the things that have always caught me off guard is, like, in Canada you have to be 19, or in Ontario you have to be 19 to, like, buy alcohol or go to a bar. I don't understand still why they need to know my postal code, where I live, you know, like, my height, eye color, all this other extra information. And, you know, it'd be cool to have it, like, on, like, an ID where it's just, like, digital. I can just say, like, this is who I am and prove it and move on with my life. I think Ukraine, you guys have, like, Ukraine's had, like, a really sick digital identity system, if I'm not mistaken.
Yes, we do.
Yeah.
Actually.
Yeah. And it's, like, it'd be sick if that stuff was, like, fully, like, ZK'd so that, like, you can give up zero information to anybody. But you're kind of already doing that. I think that's kind of, like, a really cool future for privacy, at least. Yeah, Ukraine's, like, system's actually really cool. Your digital wallet is, like,
I will try
really,
to show
cool.
it from afar so you can't really see my documents, but here we are, like, passport, like, driving license, car, and stuff like that. Yeah, I can pay a lot of things. They're about to actually automate the taxes in here for like contractors. So you just kind of, as a subscription for a government, they will just automatically get taxes out of there.
It's so ridiculous as an individual that like there's no like automated taxing system through your bank account. Pet peeve, but it's like if you don't have someone doing your tax, like a company taking the taxes off for you, it's absurd, absolutely absurd. The system built for you to fail. Like they don't want you to succeed at doing your taxes. It is such an archaic, draconic situation. Rant over.
Okay, so that's coming up to the next question, an interesting one. Talking about privacy, actually, blockchain gives you a freedom for transferring money anywhere technically. ZCash is actually allows you to transfer it to anyone without actually revealing who gets the money. Do you think it is possible to keep the privacy but reduce the fraud with the blockchain, maybe somehow in future? Because actually, like, the whole history of blockchain is kind of linked to the fraud, some scams, money laundering, and things like that. So if there is a possibility to keep the privacy for good but restrict funding of Russian army with blockchain and things like that.
Cue US fiat, US dollars, like physical bills have been doing this for years. But you know, that's like a reality too. I don't think so, because like I think if there's a way, there's a will type of saying. Like fiat dollar bills are used for the same thing. Crypto was originally used kind of like that. If you talk to people who discovered crypto in like 2011, 2012, it's probably because they were buying something online that they shouldn't have been. There was a funny tweet actually the other day. This kind of related to fraud, but like, okay, there's like, I guess there's two types of fraud here, right? There's like, I know there's a bug in the system and I'm going to exploit it. And then there's like, hey, I'm like doing illicit activities and using this as like legal tender. But when you have a system like ZCash, you actually, when you have like zero, how do I put this? I can't remember the tweet exactly, but like zero knowledge proofs imply like zero knowledge on the bugs as well. So like you don't actually know if like a bug has occurred on chain. Zcash has had this issue before where there was like, I think one of the Zcash improvement, Zcash improvement proposals, like prevented a pool from like going into a negative balance. Like that wasn't like that was like an afterthought idea. So like technically you could have inflated the supply beforehand. And so it's like, it's one of those funny things where it's like the privacy blockchains like have this problem where you don't actually know if like a double spend was made or something like that technically. It's like, yeah, fun little anecdote. I think Zuku retweeted it the other day, like 2 days ago.
The funny things about this bug that they have this vulnerability more than half year. So anyone can interact and anyone can exploit it half year, and they cannot fix it because for this one they need new trusted setup ceremony, because it was made like on the Grot 16 proving system. And if you change circuit in the Grot 16, you need to create a new trusted setup ceremony, and only when they like prepare the new upgrade, they say, okay, we have a new circuit because this is the upgrade for our system. But was not only the upgrade for a system, they also made another trusted setup ceremony for fixing this bug also. By the way, it's great that right now we have things like KZG commitments, like Plonk, proof systems that we don't need to have like specific trusted setup for each application. We just can have just general trusted setup, and you can create your own application and you can reuse the trusted setup, and something went wrong in this system. I mean, you can really do the fast upgrade without doing these things. Just okay. Let's switch to the meow and to the things. related to the RPC and wallets. And for now, we have like really huge ecosystem of MEV, minor executable value. And do we have like some impact on the way how we interact between DApps, between all of these things? Do we lose some privacy using MEV? Do we lose some usability in the case of communication between wallets or PCs using MEV?
Yeah, so if you're submitting your transactions through something like the Flashbots RPC, is that kind of what you mean by that?
Yeah. I have just strict questions. Is MEV providers a spyware? But
absolutely. I don't want to get too deep into this, but like I am really, really against. I think what the service it offers is really, really awesome. I absolutely do not trust them. You're basically asking the people who help sandwich attacks prevent your sandwich attack. I don't know. I don't buy it. I think if there's a really good opportunity in there, they're going to squeeze it. So yeah, I think they're exploiting you long term. Nothing good can come from a free service. That's all I'll say.
So thank you, Greg. Thank you for this great talk. Talking with you, I understand that we need to record 2 other episodes. One with the expert for privacy voting. Found some expert and talking about privacy voting systems, because there is a lot of problems here. And the second thing, I think we need to talk about MEV and all things related to the privacy, because there is a huge misunderstanding right now. What is MEV, how it works, etc. Thank you very much, and just few last words that if you want to support our podcast, please do not support us. Please support Ukrainian army, because it's really important to resist Russian invasion. And if you can donate to one of the biggest funds which are support Ukrainian army, which called Save Lives. So you can do it by sending crypto. So you can just find addresses for sending crypto by URL savelives.in.ua/donate-in. So you can see this address in show notes. If you're watching us on YouTube, you can see the screenshot right now on your screen. And thank you very much.
Yeah, please subscribe to us if you're on YouTube, Spotify, Apple Podcasts, Google Podcasts, Castbox, Amazon Music. Also follow us on Twitter or Telegram. We have a Telegram chat. And yeah, comment. Let us know if you have any proposals for future topics, or if there's things that we did not cover or covered wrongly, incorrectly, we will correct. And yeah, thanks for tuning in. Thank you, Gregory, for joining us today. Bye.
Thanks for having me. Bye.